Counting squares. We'll learn to count the number of squares visually and by using a formula or a pattern in this video. Let's consider a 2 by 2 grid. We have 1, 2, 3 and 4 1 by 1 squares. So total of 4 squares of 1 by 1, and we can have only one square of 2 by 2 because the grid itself is a 2 by 2 grid. So that is the biggest possible square. We have 5 squares in total. Let's count number of squares in a 3 by 3 grid and also work out a pattern or formula that we can apply to bigger grids so that we don't need to count visually every time. We have 9 squares of 1 by 1. Next size is squares of 2 by 2. We have 1. When we count the next square, we just shift by one cell in one direction. So in this row, I have 2 squares of 2 by 2. I cannot get any more 2 by 2 squares in this row, so I'll shift down just by one cell. So I'll shift to the next row. Next row is just one cell down. Third square, and this is the fourth square. So we have 4 squares of 2 by 2. Next size of the square is 3 by 3. We can have only one such square because the grid itself is a 3 by 3 grid. So that is the biggest possible size. We have one square of 3 by 3 and our total is 14 squares. Pattern, we have 9 squares of 1 by 1. For next size of square, which is 2 by 2, I will take a whole square which comes just before 9, which is 4. For next size of square, which is 3 by 3, I will take a whole square which is just less than 4, and that is 1. So I have one square of 3 by 3 and 4 squares of 2 by 2. This is how we can work out without making a figure also. Let's apply the pattern we learned to a 4 by 4 grid. We have 16 squares of 1 by 1. So we'll have a perfect square which is just less than 16, 9 squares of 2 by 2, and for next size, which is 3 by 3, we'll have a perfect square which is just less than 9. So 4 squares of 3 by 3. For 4 by 4, we'll have number of squares which is just less than a perfect square which is just less than 4, which is 1. So we have one square of 4 by 4. We cannot have a bigger square in this because the grid itself is 4 by 4. So that means in next step, the next perfect square, which is 0 squares of 5 by 5. So our total is 30 squares in total. One more pattern. We have already seen that the number of squares in a 2 by 2 grid is 5. 4 squares of 1 by 1 and 1 square of 2 by 2. What if we place one more square at the center? I'm talking about this gray square which I have put here. I already had 5 squares in the bigger one which is present here. I put one more square. So this square is very similar to this square in the sense that this has 4 divisions, 4 squares of 1 by 1 and one big square of 2 by 2. So in total we'll have 5 squares for this green square and 5 squares for the square with gray outline. In total 10 squares. Let's consider a 6 by 4 grid, which is a rectangular grid. I'm intentionally taking a big grid so that we can clearly observe the pattern. We have 4 into 6, 24 squares of 1 by 1. Next size is 2 by 2. We have 1, 2, 3, 4, 5 such squares in one row, but there are more rows. Shift one row down. Now in this row also, I'll have 5 squares of 2 by 2. There's one more row in which I can have squares of 2 by 2. Again in this row, we have 5 such squares. So total 3 into 5, 15 squares of 2 by 2. Next size is 3 by 3. We have 1, 2, 3, 4 squares in one row. Shift one cell down, one more row is possible. Again, 4 more squares in the next row. So total 2 into 4, 8 squares of 3 by 3. Next size is 4 by 4. We have 1, 2, 3 such squares. We cannot have any squares of 5 by 5 because the grid itself is just 4 by 6. So 0 squares of 5 by 5. Total 50 squares. Do you observe the pattern here? We have 4 into 6, 24 squares of 1 by 1, which we can directly count by multiplying number of rows with number of columns. Now, in next row, for next size of square, what do we have here? 3 into 5. 3 is 1 less than 4, 5 is 1 less than 6. So we just reduce number of rows and number of columns by 1 and multiply them. So 3 into 5 is equal to 15 squares of next size. Now for next size, which is 3 by 3, we'll reduce the number of rows and columns again. So 3 minus 1, 2, 5 minus 1, 4, 2 into 4, 8 such squares of 8 squares of 3 by 3. Again, reduce by 1. 2 minus 1, 1, 4 minus 1, 3. 1 into 3, 3 squares of 4 by 4. We reduce by 1 and get 0 here. So obviously 0 squares of 5 by 5. Total 50 squares. That means we can calculate this by counting it visually or by using the pattern or the formula that we saw here. Quiz time. Count the total number of squares in the given figure. Take 5 seconds. If you want more time, please pause the video, solve your question, and start the video again. We have 4 into 5, which is 20 squares of 1 by 1. 3 into 4, which is 12 squares of 2 by 2. 2 into 3, which is 6 squares of 3 by 3. And 1 into 2, 2 squares of 4 by 4. 0 squares of 5 by 5. In total, 40 squares. Next question. Count the total number of squares in the figure. We have seen this pattern. We have 5 squares in the bigger square, which is 4 squares of 1 by 1 and 1 square of 2 by 2. Similarly, 5 squares in the square with gray outline and 5 squares in the square with blue outline. So total 15 squares. Next question. Count the number of squares. Yes, you're right. It's 10. 5 squares in the outer square and 5 squares in the inner gray square. We have made 2 extra lines here, but they have created extra triangles and not extra squares. So there are no extra squares created by these blue lines. Hence we'll have total of 10 squares only. How many squares are there in a 5 by 5 grid? We don't need to draw the grid here. We can use the pattern or the formula that we just saw. So take 5 seconds. If you want more time, please pause the video and solve your problem. Start the video again. We'll have 25 squares of 1 by 1 because it is 5 into 5 grid. Whole square, which is just lower than 25, is 16. So we'll have 16 squares of 2 by 2 of next size. Similarly, 9 squares of 3 by 3, 4 of 2 by 2, 1 of 3 by 3. Total 55 squares. Next question, how many squares are there in a 3 by 5 grid? We have 3 into 5, which is 15 squares of 1 by 1. So we'll have 2 into 4, 8 squares of 2 by 2. It is a rectangular grid. We have to use the pattern for rectangular grid that we saw in the video earlier. And 1 by 3, which is 3 squares of 3 by 3. So keep reducing number of rows and columns by 1 and you get the number of squares of next size. Total 26 squares. Next question, count the number of squares. We'll first calculate the number of squares in the square grids, which are blue, maroon, and gray. So for each of them, we have 4 squares of 1 by 1, 1 square of 2 by 2, which is 5 squares in total, as we saw in the pattern. For 3 such grids, we have 15 squares. Now, the number of squares in green grid. Formula for square grids and rectangular grids are entirely different. We have 2 into 4, number of rows into number of columns. That is equal to 8 squares of 1 by 1. And 1 into 3, which is 3 squares of 2 by 2. We cannot have a 3 by 3 square here. And total is 11 green squares. Hence, we have total of 15 plus 11, 26 squares in this figure. Hope this video was helpful. Like, share and subscribe for more such videos. If you want videos on any reasoning or maths topic, send your suggestions to mathelogical001@gmail.com. Thank you.